All right. In this video, we're gonna focus on units and dimensions. Units and dimensions. Now, before we solve some questions here, let's take a note. Please write. Units can be expressed in two ways. Units can be expressed in two ways. One, let's take the first one here. One, name method. Two, that is the second way, formula method. Let me recap myself again. Units can be expressed in two ways. The first one here is name method. The second one here is formula method. So let's understand name method and also understand the formula method. And after then, we know the best method that can be used. Okay. Now please write name method. Let's take the first one here, class. Let's take the first one here. Name method. Okay. Let's take a note here. Using the name of the discoverer to express a unit is known as is known as name method. Okay, using the name of the discoverer to express a unit is known as name method. Okay, let me explain here. Now, whenever you use the name of the person that discovered that particular quantity, whenever you use the name of the person that discovered that particular quantity to express the unit, that method is name method. For example, Isaac Newton discovered force. So expressing force as Newton, that particular unit is known as name method. Pascal discovered pressure. Pressure as Pascal is known as name method. Jokes discovered work done. So expressing work done as jokes is known as name method. Please take note. So whenever you are expressing the unit of the quantity with the name of the person that discovered that particular unit, that particular quantity, we call that method name method. Please take notes. So for example, for a full stop here, for example, force as Newton, pressure as Pascal, work done as Joules. Please take note. So this is what we call name method. So now let's explain the next method, okay? Before we solve a particular question here, please let's take the next one here, class. Two, formula method using formulas to express a unit is known as formula method. Okay, now let me explain this, please. Whenever we are using the formula of that quantity, please listen to me carefully. Whenever we are using the formula of that quantity to express the units, that particular method is known as formula method. That particular method is known as formula method. And this is the best method to express any units. Please take note. Whenever you're asked to express any unit in any exam, the only method to use is formula method, okay? Now let's take a note here before we solve some question. Please write, note that, take a note here, note that to express unit using formula method, note that to express unit using formula method, the formula must be known. Okay, let's take a note here. Note that to express unit using formula method, the formula must be known. Please take note. So if I want to express the unit of any formula, the first thing that I have, the first step I have to take is to write down the formula. Please take note. Whenever you want to express the unit of any quantity at all, the first thing is to write the formula, okay? So now let's take the steps in calculating units using formula method. Please write steps in calculating units using formula method. Let's take the steps in calculating units using formula method. Okay, the first step here, that is step one. Step one. Okay, one. Step one. Know the formula of the quantity. That is, write down the formula of the quantity. Okay, you first of all write down the formula of the quantity. Let's take step 2. Step 2, reduce the formula to its fundamental quantity. Reduce the formula to its fundamental quantity and simplify. So class, these are the steps to take whenever you want to calculate any unit using formula method. We are going to apply them one by one. Okay, the first step here is to write down the formula of the quantity. So if you're asked to calculate the unit of speed, the first thing you have to do here is to write down the formula of speed. Okay, now after then you can now reduce the formula of of speed. Sorry, you can now reduce the formula of speed to its fundamental quantity. So we are going to know what fundamental quantity are. Okay, we are going to know what fundamental quantities are. Okay, now let's know what fundamental quantities are. Okay, all right, let's know what fundamental quantities are. Okay, now let's know the fundamental quantities and their units. Okay, fundamental quantities. Okay, the first fundamental quantity is mass and the unit is kg. The second is length and the unit is meter. The third is time and the unit is seconds. Please take note. So class, the question now is, what is the use of fundamental quantities? Now listen to me carefully. Whenever you are asked to, whenever you are given a quantity, to express that quantity in, to express, whenever you are given a quantity, to express the unit of that quantity, please listen to me carefully. Whenever you are given a quantity and you are asked to express the unit of that quantity, the first step you have to take is to write down the formula. The second step is to reduce that formula to its fundamental quantity. So these are the fundamental quantities here. That is mass, length, and time. So that means the formula can be classified as either mass or length or time. Please take note. So anything that is not of mass and time should be under length. Please take note. And if they are mass, or if that quantity is mass, it's going to be specified. Okay, if that quantity is time, it's going to be specified. Okay, so let's solve a question here to understand the note perfectly. Okay, please write example 1. Let's take example 1 here. That is question 1. Question 1. Find the unit of speed. So we are asked to find the unit of speed, of course. First, let's take the solution. So remember, the best method to use here is formula method. And we are given a note that whenever you are using formula method, that the formula must be known. And also, we are also given a steps on how to calculate unit using formula method. And the first step is to write down the unit, okay? Write down the formula, sorry. The first step is to write down the formula, okay? Now let's write down the formula of speed. The formula is distance over time. Please take note. So I'm going to list out the formulas you need to know, okay? All you have to do is to hit the subscribe button, or you can follow us on TikTok, okay? So all you have to do is to hit the subscriber button, okay? So class, the first thing you have to do is to write down the formula, okay? So this is the formula for speed. So the next step is to reduce the formula to its fundamental quantity. So now let's classify this distance here to its fundamental quantity. Let's classify this distance here to its fundamental quantity, okay? Now when you go back to the fundamental quantity, distance cannot fall under mass. Distance cannot fall under time, okay? That means distance should be under length. And what is the unit of length? Meter. Please take note. So writing down the unit, I will have this to be equal to meter over, of course, this time here is already in its fundamental quantity, and the unit is seconds. Please take note. Okay, now this is the answer, but it must be expressed in a linear form, not in a fraction. Please take note. Whenever you're expressing a unit, it must be expressed in a linear form, not in fraction. Please take note. Now, how do we express this here in a linear form? How do we express this in a linear form? Okay, before we express this in a linear form here, there is a law we have to understand. Please understand that if I have something like this in mathematics, that is 3 over 2 is the same thing as 1 over 2 times 3. Please take note. That is, this 3 multiplied by 1 will give us this 3 over 2. Please take note. So expressing this guy here as that means speed is equal to meter times 1 over seconds. Please take note. So this is the same thing as meter times meter will give us meter over seconds, which is this one here. So there's a law in indices that if I have this as 1 over s is the same as s raised to power minus 1. What does it mean here? It means that whenever you are taking anything from denominator to numerator, the sign of the power will change. Whenever you are taking anything from denominator to numerator, the sign of the power will change. Please take note. So the same thing here, whenever you are taking anything from numerator to denominator, the sign will change. So there's an invisible one here. There's an invisible one here. Taking s raised to power of 1 from denominator to numerator, it will be s raised to power 1 over 1. Okay, applying this law here, there's an invisible one here, class. Please take note. That means taking s, it's not s, it's s now. Taking this s raised to power of 1 from denominator to numerator, I'm going to have this going to be meter times s raised to power minus 1. So there's something you have to understand here, that if I have this as in mathematics, if I have this as s times y is the same thing as sy, that is combine them together. Whenever you are multiplying letters, you combine them together. So the same thing here. I have this as meter times per seconds. The answer is going to be class meter per seconds. This is my answer here, okay? So this is how we express unit. Please take note. So let's take the next example here, class. Let's take the next example here. Example 2. Example 2. Find the unit of velocity. Class, we are asked to find the unit of velocity. So let's first of all take this question one by one, or take the step one by one. Let's first of all take the step one by one, okay? So the first thing, solution first. So class, we are asked to find the unit of velocity. Of course, the best method to use here is the formula method. And calculating any unit using formula method, the first step is to write down the formula. Class, let's write down the formula of velocity. Velocity is equal to displacement over time. Please take note. So the next step is to reduce the formula to its fundamental quantity. So now let's classify displacement to its fundamental quantity. Displacement can be classified as length. Please take note, because it's not of mass, it's not of mass, and it's not of time. Please take note. So it's going to be of length. Please take note of this. And the unit of length is meter. So when you do that, I will have this as meter, sorry, I will have this as meter per seconds. Please take note. The seconds is as a result of time. The unit of time is seconds. So class, this is the answer, yes, but all unit is always expressed in a linear form, not in a fraction. Please take note. So how do we express this in a fraction? Okay, how do we express this in a linear form? It's already in fraction. How do we express this in a linear form? Class, remember that this, whenever I have something like this, remember that whenever I have something like this, 3 over 2 is the same thing as 1 over 2 times 3. Please take note, okay? So applying this law, velocity, which is meter per seconds, is the same thing as meter times 1 over s. Please take note. And we also have a law that if I have something like this, 1 over s, that is the same thing as s raised to the power minus 1. Please take note of this, okay? Of this law, very important. So class, what does it mean here? It means that whenever you are taking anything from denominator to numerator, the sign of the power will change. There's an invisible one here attached to this particular power. Please take note. So taking s raised to the power of 1 to numerator, it will be s raised to the power minus 1. Please take note. So the same thing here, whenever you are taking anything from numerator to denominator, the sign will change. Please take note. So I'm taking this guy here, this s raised to the power of 1 here, from denominator to numerator. This is going to be equal to class meter times s raised to the power minus 1. So we have a law that whenever you are multiplying two letters, all you have to do is to combine them together. If I have this to be s times y, the answer will be sy. So that means velocity will be equal to class meter per seconds. Please take note of this, okay? So the unit of velocity and speed is the same. So let's take the next one here, example 3. Let's take the next one here, example 3. Example 3. Find the unit of acceleration. Find the unit of acceleration. Find the unit of acceleration. Solution here. Okay. Remember the first step. Of course, the method to use is formula method. The first step is to write down the formula of acceleration. Acceleration is equal to velocity over time. Now, we are not saying change in velocity over change in time because we are not having two velocities here. Please take note. We express acceleration as change in velocity over change in time when we have two velocities and two times. Please take note. If you have two velocities and you have t1, t2, that is two times. So at that point, you can now express your acceleration as change in velocity over change in time. Please take note. But if you have only one velocity, it's going to be velocity over time. Please take note of this. So we don't have any v1 or v and u. So our acceleration will be expressed as velocity only. Now we don't have anything like t1 and t2. So our time will be expressed as time. Please take note of that. Okay. So remember, we have already solved for this velocity here as meter per seconds. So now let's replace the unit. Replacing the unit here, we'll have this to be meter per seconds over seconds. Please take note. And we know that in expressing the unit of any quantity, it must be expressed in a linear form, not in fraction. So let's express this in a linear form, okay? Now expressing this in a linear form, I will take this s at the denominator part to numerator. When you do that, we have acceleration to be this. Acceleration when you do that, we have acceleration to be this, that is meter per seconds times per seconds. So class, there's a law in indices, and that law states that whenever we have two bases, we take only one and add up their powers. So if I have something like this class, if I have something like this, a raised power of m times a raised power of n, the answer will be equal to a raised power of m plus n. So this is the law of indices. So whenever I have two bases, you take one and you add up their powers. So we have two bases here. We have s raised power of minus 1, s raised power of minus 1. So you take only one and add up their powers, okay? So I will have something like this class. When you do that, acceleration will be equal to meter per seconds plus, the plus is as a result of these times here, please take note, plus into minus 1. The minus is as a result of this power here, please take note. So in mathematics, plus times minus will be minus. So I will have this to be class equal to meter per seconds minus 1. So minus 1 is going to be minus 2. You are owing 1 and you are owing 1. So you are in total you are owing 2. Please take note, minus 1 is not plus 1. plus 2 is minus 2. So I will have this to be equal to class meter per second square. This is my answer. So let's solve some advanced questions here. Please write. Let's solve some advanced questions here. All right. Let's solve some advanced questions here. Okay. Example 4. Find the unit of force. All right. We are asked to find the unit of force. Solution. Okay. The first thing here, please, if the formula is your problem, maybe you don't know how to write down the formula, please just comment on the, just comment. Okay, just comment and it will be sent to you. If the formula is the problem, just comment and it will be sent to you. Okay, so let's write down the formula for force. Now the formula for force here, the formula for force is equal to mass times acceleration. Please take note. Okay, the formula for force is mass times acceleration. Remember, the first step is to write down the formula, and the formula for this force here is mass times acceleration. The next step is to reduce the formula in its fundamental quantity. Of course, this one here is already in its fundamental quantity, and the unit is kg times, we know this one already, which is acceleration, and the unit is meter per second square. So I have this to be meter per second square. Please take note. Okay, I have this to be meter per second square. Okay, now class, remember that whenever you have something like this in mathematics, s times y, this is letter. So whenever you are multiplying two letters, the result of this is going to be the combination of it, that is s y. Please take note. If I have s times y, the result will be sy. So let's apply the same law here. I have kg times meter per second square. So the result of this is going to be equal to kg meter per second square. So this is the formula here. This is the unit here. So class, there's a shortcut I want to give to us here. And you can only understand that shortcut if you know the unit of force. Remember, the unit of force is the combination of mass and acceleration. So if you know the unit of force, you can easily solve, you can easily express your unit. If you know the unit of force, you can easily express any unit at all. Okay, now we all know that the unit of force is kg meter per second square. Okay, now let's write down the next, let's solve the next example here. Example 5. Write down write down the unit of work done. Write down the unit of work done. Okay, now let's solve this. Remember, the first step is to write down the formula. So let's write down the formula for work done. But there's something I want to tell you here. Work done and energy is the same. So if you're asked to write down the unit of energy, is the same thing as work done. Please take note. So the formula for work done is equal to force times distance. Please take note. So we know the unit of force already. So replace the unit kg, replace the unit here, kg meter per second square times meter, okay? So class, we have 2 meters here, that is meter. So whenever we have two bases, remember the law, whenever we have two bases, we take only one and add up their powers. So I will take this guy here, this will be equal to class kg meter 1 plus 1. So there is invisible one here, there is invisible one here, please take note. So you add up their powers, so it will be 1 plus 1, you write down per second square. So remember, listen please, remember we are arranging this unit here, according to the fundamental quantities. Remember, we are arranging this unit here according to the fundamental quantities. That means kg comes before meter and meter comes before seconds. So in summary, whenever you are writing any unit, the unit must be arranged according to the fundamental quantities. Please take note. So kg comes before meter, meter comes before seconds. Please take note. So let's simplify this down here. This will be equal to kg meter square per second square. This is the unit of work done. Please take note. This is the unit of work done. So let's solve an advanced question here um before we introduce dimension. Let's solve an advanced question here before we introduce dimension. Please take note, okay? Now, example 6. Example 6. Example 6. Write down the unit of Young's modulus. Example 6. Write down the unit of Young's modulus. So the first thing I have to do here, please listen to me carefully. The first thing I have to do here is to write down the formula of Young's modulus, okay? So solution, let's solve this question together. So the formula for Young's modulus is equal to tensile stress over tensile strain. Tensile stress over tensile strain. Please take note. So we have to know what tensile stress is, and we have to know what tensile strain is. Please take note. So class, the formula for tensile stress is equal to force over area, and the formula for tensile strain is equal to extension over original length. The formula for tensile stress is force over area. The formula for tensile strain is extension over original length. Please take note. So we have to express this one by one. We have to replace this particular formula here and replace this guy here. Replace this guy here. Please take note. So when you do that, we have something like this: Young's modulus. The symbol is always alpha or e. So in your secondary school, you use alpha to represent Young's modulus, but in your advanced level, you use e to represent Young's modulus. Please take note, depending on your level, okay? So this will be equal to class force over area over extension over original length. So LO is representing original length. Please take note. So now let's try to represent this. We know the unit of force. We have done that, and the unit is kg meter per second square over. Now let's know the unit of area. But before we know the unit of area, we have to know the formula for area. And the formula, let's know it's somewhere else here. Let's just create a space here. Let's write it somewhere else here. And the formula for area is length times breadth. And this length here can be classified as length in fundamental quantity. The unit is meter. Please take note. And this breadth here cannot be classified as mass, nor can it be classified as time. Please take note. So since it cannot be classified as mass, cannot be classified as time, so it will be length, and the unit is meter. So meter times meter will give us meter square. Please take note. So I have this as meter square. This is my area. Please take note. So extension over extension. Extension is length. So this will be meter over original length is also length. So this will cancel this. Please take note. I'll be left with this. I'll be left with E, that is Young's modulus, is equal to kg meter per second square over meter square. So the meter at the numerator here, we cancel the meter at denominator. I'll be left with 1 meter at denominator. Please take note. So I will have this to be kg per second square over meter. Please take note. So class, expressing this here in a linear form, that means I have to take the meter at denominator to numerator. When you do that, remember there's an invisible one here, and whenever you are taking anything from denominator to numerator, the sign of the power will change. But the question now is, if I'm taking this m raised to 1, is it going to be before kg? Is it going to be here before kg, or is going to be here at the middle of kg per seconds, or is going to be after per second square? So some of you guys failed. Some of you guys said it's going to be here. Some say it's going to be here. Why some got it that it's going to be here, right? Now listen. Now, whenever you are arranging units, you always arrange them in order of their fundamental quantities. We always arrange units in order of their fundamental quantities. That means kg will come before meter. Meter will come before seconds. Please take note. So if I'm taking this meter raised to 1 to numerator, the sign will change. So it's going to be at the middle here because kg will come before meter, right? So the answer to this is going to be E equal to kg per meter per second square. So this is my answer here. Please take note. kg per meter per second square. So all you have to do is to hit the subscriber button to get more advanced question on unit and dimension. Okay, thank you.